Hello and welcome back to Statics. In this example, we will be looking at textbook problem 2.23. You see it before you. If we read it through, it says three forces act on the pile as shown. If the resultant of the three forces is equal to 500 newtons and is directed vertically, determine the magnitude and the direction of S. So this is technically a four-force problem. It's not a four-force problem in equilibrium, but it's a four-force problem that has a resultant. But it does take four forces into consideration, and it is a situation where we have two unknowns, right? The unknowns are the magnitude of S and the angle for S. Okay, so here's our diagram, and now I'm going to pause the video for a second, and I'm going to set this up on my worksheet. All right, so here it is. It's problem 3.23. This is the 7th example in here. As with all the other examples, I recommend you go through this yourself, use your calculator, and try to get the same results I get. That'll give you the practice you need to be successful in the homework and in the quiz. If you follow along, we have the diagram is shown down here, right? So we have a pin in the ground. And then we have describes a pile in the ground. Then we have a 75 Newton force acting 40 degrees above the negative horizontal. 35 degrees above that, we have Q, which equals 100 newtons. And then we have an unknown force, S, acting at theta. We don't know the magnitude. We do know the resultant of all these forces added together is 500 newtons, and it was described as acting vertically, so I'm going to list this as acting at 90 degrees. Right? Two things they want us to find is the magnitude and the angle for force S. So in terms of the solution, I'm a big fan of using this table. It's a nice way to organize it. You have your force, your magnitude, your angle, f of x and f of y. We're going to solve this using summation. That's really the only effective way of solving four-force problems. We could definitely combine the P and Q with a triangle, find the resultant of that, and then use that to solve for S. But that's a multiple-step process. It adds a lot of problems potentially with round off and opportunities for algebraic errors. So really, once you get above three forces, you really have to use summation. And again, this is one of those problems that can be solved using determinants if that's something you're familiar with. So in terms of P, we know that's 75. I got it listed in newtons, so we don't have to write that up there. Q is 100. S, in this case, is unknown, so I will just list it as S for now. In terms of theta, if you recall, I'm a big fan of always measuring these with respect to the positive horizontal. And if you recall, our sign convention shows that everything positive starts there, and we have positive x and positive y. If we take a look at this, this would go to 180 degrees and back 40 for P, so this would be 140 degrees. Right? And then for Q, it would be 35 less than that, or 105. Right? The fact is, if you do this with respect to the positive horizontal, you will always get the right signs, whether they're for your x, f of x, and f of y's. And then, of course, down here, we don't know what it is. So it's theta. So if we take a look at this, we know that this one down here is just going to be S cosine theta, and this one down here is going to be S sine theta. Right, because those are our two unknowns. Now, these, on the other hand, we can solve for. If you take a look, we can say 75 times the cosine of 140. Right, that gives us minus 57.5. Again, I'm going with three significant figures. We can then do 75 times the sine of 140. That comes out to be 48.2. Similarly, down below, we have 100 times the cosine of 105. That gives us minus 25.9. All these are in newtons, by the way. And then the last one is 100 times the sine of 105. And that gives us 96.6. as I recommend you do in all of these, make sure that your answers make sense. The fact is both of these are less than 75, which has to be the case for components. X is negative and Y is positive. That indicates the second quadrant, like it is. They're pretty equal, so the angle should be right around 45 degrees, which it is. X a little bigger than Y. On the other hand, the Q force here is far more vertical, and as a result you have a Y component that's much larger than the X component, but again in the second quadrant. Okay. One thing that's kind of nice about S is that it is in the first quadrant, so we don't really have to worry about signs and things like that. So in terms of setting these up, we know that they have got to sum in terms of X to 0, and keep in mind this is going to be, they're going to sum to our resultant, skipped a step, Rx. And because our X is, our R I should say, is vertical, there is no horizontal component. So this does have to sum to be equal to 0. Right? Similarly, if we go over here, we have a setup where our sum of Fy has to equal R sub y. And again, this is a vertical force, 500 newtons acting upwards. So this has to equal 500. I'm going to write these out in equation form. Just pause the, well, I can do this pretty quickly. We have, for X, we have minus 57.5 minus 25.9 plus S cosine theta equals 0. All right. As a result, we have, therefore, S cosine theta equals minus 57.5 plus 25.9. Just make sure I don't mess up my math. 83.4. These are both negative. They move to the other side, so it's positive 83.4. All right. Down here, we have Y. All right. We have our two values, 48.2. All right. Plus 96.6 plus S sine theta equals 500. All right. So we can rewrite this, of course. S sine theta is going to be equal to 500 minus 48.2 minus 96.6. All right, so that comes out to be 355. Okay, so now we have two relationships with two unknowns. They're not the standard format that we're used to, where we have a coefficient times one variable plus a coefficient times another variable maybe equals a constant, but they still can be solved using substitution. So let's take a look at the first one. We have S cosine theta equals 83.4. What we want to get is S on one side and theta on the other. And the simplest way to do this is just divide out cosine theta. If you do that, you'll get that S is equal to 83.4 divided by cosine theta. If you then take that and plug it into the equation down here, right, you can have for S 83.4 divided by cosine theta times sine theta is equal to 355. If you go through and do the math, you get sine theta over cos theta equals 355 divided by 83.4. And if you do the math there, 355 divided by 83.4 gives us 4.26. And you may be saying to yourself, well, how's that going to work? The fact is I still have sine theta and cosine theta over here. But keep in mind, sine theta and cosine theta is equal to tangent theta. Remember, sine theta divided by cosine theta is into that? So what we can say is theta is equal to tangent to the minus 1 of 4.26. When I plug that in, we get 76.8 degrees. All right? And we can then plug that right in above, because keep in mind we have S is equal to 83.4 divided by cosine theta. So we have S is equal to 83.4 divided by the cosine of 76.8. Right. So we put that right in there. 83.4 divided by cosine 76.8. And we hit equals. And we get a value of 365. And that, of course, would be newtons. All right, so the fact is we have our S, right? And we can say S is equal to 365 newtons at 76.8 degrees. And there we go. And that's our answer.